Slack is an application for team communication. Users chat across mobile devices, web browsers, and a desktop application, which means that Slack has 3 places to deploy on, rather than the more traditional 2 places, where you would just have a mobile device and a web browser. And the desktop apps on Windows and Mac and Linux are not identical, so Slack has even more places to deploy with all the variation in operating systems. With so many different runtime environments, Slack needs to make technology choices that reduce the chance of errors. Typescript allows for static typing of JavaScript. The extra compilation step checks the types of variables being passed between different places, so the errors will be discovered at compile time. In an untyped world, these errors might occur at runtime. Typescript also unlocks the ability to put JavaScript code in an IDE, allowing for more efficient development. Felix Rieseberg is a desktop engineer at Slack, and in today's episode he explains the unique challenges of building Slack and why the team moved from JavaScript to TypeScript. Spring is a season of growth and change. Have you been thinking you'd be happier at a new job? If you're dreaming about a new job and have been waiting for the right time to make a move, go to hired.com/sedaily today. Hired makes finding work enjoyable. Hired uses an algorithmic job matching tool in combination with a talent advocate who will walk you through the process of finding a better job. Maybe you want more flexible hours, or more money, or remote work. Maybe you want to work at Zillow or Squarespace or Postmates or some of the other top technology companies that are desperately looking for engineers on Hired. You and your skills are in high demand. You listen to a software engineering podcast in your spare time, so you're clearly passionate about technology. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $600 signing bonus from Hired when you find that great job that gives you the respect and the salary that you deserve as a talented engineer. I love Hired because it puts you in charge. Go to hired.com/sedaily, and thanks to Hired for being a continued long-running sponsor of Software Engineering Daily. Felix Rieseberg is a desktop engineer at Slack. Felix, welcome to Software Engineering Daily.
Hey, how are you doing?
I'm doing quite well, and I've been using Slack all morning. It's one of my favorite products. And the Slack desktop app is entirely written in JavaScript. And today we're going to be talking about TypeScript. But before we get into TypeScript, let's motivate that discussion and talk about programming within a large JavaScript codebase. What is difficult about managing a large JavaScript codebase?
So I think Slack might be one of the more unique cases. What is going on is that Slack is using a framework called Electron, which allows us to do all the easy parts in JavaScript and HTML. And then we have a thick layer of C++ around it that is responsible for the quote-unquote difficult parts. So for the things that you would consider to be a little bit more advanced, something like the video calls that are available in Slack today, those are in C++. And then we have a thick layer between those two worlds that combines those two worlds. And even if you do not call into something native, even if you don't call into C++ regularly, I personally feel like managing large JavaScript code bases has always been troublesome because the distance between your code and the code that you might be interacting with increases over time and with the complexity of the code base, right? So if you have just one file and you're calling a certain function, it's very easy for you to see immediately where the function goes. It's either like immediately above or below your code. But as applications become more serious and as applications grow in size and complexity, the location of that code that you're interacting with might just be further from your location. And that makes things pretty difficult sooner or later, right? Because in so many cases today, if you have NPM dependencies or you have various dependencies, you don't even know what the code looks like. You don't really know how the code behaves. And it's very hard to make assurances about what the code is going to do at runtime, right? And I think that is really something that the community has been grappling and, that's something the community had trouble with for a long time at this point. We had JSDoc and various other solutions to try to help us with that, but there has never really been a good solution that was like, here's a function, and I can guarantee to you that this function will always return X. And if it throws, it will always throw X.
Yeah. So just as we're talking about the architecture of Slack, we actually did a show about Slack's architecture. And I think I remember much of it being in PHP. Is there still much of Slack that's written in PHP?
Oh, so the backend is completely in PHP. I mean,
Okay,
not completely, but the majority of it, yeah. So the Slack application that you have on your desktop, it basically is something very akin to Visual Studio Code or WordPress or WhatsApp. It's this HTML application built into Chromium that gets to make full use of Chromium and its native code base. And that application then interacts with the backend. And the desktop app, the one that you interact with daily, that one is pretty much entirely React, TypeScript, and then, as I said, there's like pretty thick layer of C++ around it. But most visual elements they interact with, and most of the lifecycle events, what the application does at start, how it shuts down, how it saves data, we can write all of that in JavaScript, which gives us that easy ability to write a cross-platform app with what we consider to be a pretty small team. The desktop app team at Slack is a whopping 4 people at this point.
Wow. So if I'm using the Slack application on Windows or Mac or Linux, is the back end the same? Is it, or sorry, the front end, the back end for the front end, the C++ layer that's sitting on my desktop and doing some of the lower level desktop work? Are those applications all the same, the C++ part?
Yeah, excellent question. So the C++ part is not the same. That really depends on your platform. A good example would be notifications. The way we send notifications on Windows, we do it natively, right? So it shows up in the Action Center, and you get those like little beautiful Windows notifications that you expect, are completely different from the ones we send on macOS, where we use Objective-C. But everything else that could be cross-platform, right? Like the input menu or the channel list or your team selector on the left if you have multiple Slack teams, all of that is cross-platform. So everything that is TypeScript is cross-platform, and we just write it once, and it runs on all platforms that we support. It's pretty amazing.
The consequence here is you've got JavaScript that is interacting with native code. So on macOS, it's Objective-C. If you have these platform-specific things, this desktop platform-specific things, for example, what are some best practices when you're writing code that's going to pass, because you've got to pass objects between JavaScript and the native desktop client. If you get a notification in Slack and you want to see that notification in your whatever your native notification panel is, there's got to be an object handoff between the JavaScript code and the native code. So what are some best practices when you're writing code that's passing objects between languages?
Yeah, that's an excellent point. That's something we thought about for a very long time, and I want to say this is probably the main motivator for us to ultimately go with TypeScript. Operating systems, especially on a lower level in Objective-C and C++, are pretty unforgiving if you give them wrong stuff, right? And V8 is doing a very good job, V8 being the JavaScript engine that is built into Chrome and Node.js and is also built into Slack, the desktop app, is extremely good at bridging that transition, moving from the JavaScript world into the native world. It's very good at that. But still, if you give it a broken object, the operating systems are usually pretty unforgiving. And what I mean by pretty unforgiving is that it's not that you just wouldn't get a notification. In most cases, the whole application would just crash, right? And if you're doing some even lower level stuff in the COM world on Windows, if you write incorrect JavaScript that eventually ends up in pure memory, you can absolutely blue screen your computer, right? That is something that nobody's interested in. So in the past, what we've done is we just triple and quadruple tested our code. Despite our team being very small, we have an equally sized quality assurance team, and we have people that, in addition to our unit tests, basically test the hell out of our application. And then we also used JSDoc in the past. But with all best practices, I think as long as you have human error involved, it's very likely to still make a mistake, right? Because if you use JSDoc, which I think is pretty much the next best thing to guaranteeing how code behaves, you really rely on the former developer to have made good JS doc comments and have not made mistakes, right? And casting mistakes, I think in JavaScript are extremely common. There's some solutions in the aerospace industry, usually applied to C and C++, which are pretty strict, right? They're basically saying like a function should always fit on one computer screen. It should not be longer than 100 screens. It should not make any mutations to parameters. One input, one output, right? There's some pretty hardcore rules you can employ if you want to make guarantees about your code. But I think JavaScript not having a compiler makes it pretty hard to not shoot yourself in the foot eventually.
Yeah. Well, let's get into that. Some people are probably unfamiliar with this idea of adding a static typing layer to JavaScript. So that's what TypeScript does. TypeScript is a language where it's statically typed. So in JavaScript, you don't have to give a type to your variable. It's a dynamically typed language. TypeScript adds static typing, so it forces you to add, or I think it's optional to add types. Why is it useful to have a type system introduced to an untyped language?
Yeah, I think that's an excellent point. That's a question I keep getting quite a bit, especially when we introduce TypeScript to newcomers that come to Stack or when I talk about TypeScript at conferences. At the very basic layer, JavaScript already has something that is akin to types, right? We all have used type off at some point, and it's broken in various ways. But in theory, JavaScript has some very basic and primitive types. And you constantly do some basic checks where you see if something is an array or if it's an object, and you perform certain operations and you expect certain properties to be present on an object that you receive. What TypeScript really does at the very basic layer, if you just activate TypeScript on your existing JavaScript code, which by the way is something you can do, and that was a huge benefit. We should get into that later. But TypeScript, if you can activate it on a naked JavaScript file, vanilla JavaScript, ES6, ES5, it doesn't really matter. And it will immediately try to deduct types as it understands them from vanilla JavaScript, right? If you have a function that accepts an array, and it will understand that you're trying to accept an array because maybe later on you're trying to call for each on the parameter. If you try to call that method with, let's say, a number, TypeScript will eventually tell you, hey, by the way, just so you know, you're trying to pass a number into this function, and then the function will later take that number and try to call for each on it. That's not going to work, right? So at this very basic layer, without you describing your own types, it tries to use JavaScript's internal types to help you make basic mistakes between strings, numbers, arrays, objects. Mm-hmm. And once you start playing with that, once you start enjoying that, right, sooner or later you will have an object. Mm-hmm. And in theory, in JavaScript, all objects are more or less equal, right? Passing in an empty object is basically the same as passing in a different object, but sooner or later you want to define certain things. If we stick with our notification example, right, we absolutely need a notification object to have a body filled with a string that needs to be there. So then you enter the great world where you can tell TypeScript, hey, TypeScript, just so you know, in this parameter, I'm always expecting an object that contains the body property. And that body property should not be empty and it should be a string. Mm-hmm. And once you define that, you don't really have to worry about making mistakes ever again because TypeScript will warn you should you ever try to pass something in that doesn't have that property. Mm-hmm. And then going one step beyond that, and then I'm going to shut up, but going one step beyond that, I think one of the most common mistakes is actually not that you have a string and you accidentally pass in a number. One of the most common mistakes is that people assume that properties are present that may or may not be present on an object. Right? So if we stick with our notification example, let's actually stay within the Slack world and the notification example. Somebody passing in an object that doesn't have a body seems extremely unlikely, but we have all these extra properties that we may or may not use, right? We have something like images or like an avatar, and that avatar may be local or might be remote. So the most common mistakes is that somebody's passing something in that doesn't have all the properties, and then in the end, somebody in the actual method, the person who implemented the method, did not make clean assurances to check whether or not certain properties are present. And then I think everybody has run into the error at least once, where you try to access a property on an object that is undefined.
Right.
And JavaScript blows up, right?
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure. plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you have not tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to get a free t-shirt and support Software Engineering Daily. Our deepest thanks to Datadog for being a continued sponsor of Software Engineering Daily. Absolutely. And, like one example would be if you pass a user object from one place to another, a user obviously is going to have a name, but does it have first name and last name, or does it just have name? And if you try to access the wrong one, like if you try to pass a user variable somewhere and you try to access first name when it just has a name property, then you're going to blow up. And oops, like it would have been much better to catch that mistake at compile time rather than at runtime.
Yeah, exactly. Or even better, that's my recommendation. I feel like TypeScript actually allowed me to stop thinking as much. Once you add TypeScript to your editor of choice, right? Visual Studio Code, Sublime, Atom, whatever you use, your editor will just know if you did the right thing or not. And it will give you those like nice, comforting, squiggly red lines that tell you made a mistake.
Right.
Right? That's really nice.
So my evolution as a programmer was I started programming in college, and the introductory language for us was Java. I know a lot of people don't come in through Java, but for me it was Java, and it was a typed language. You say int x equals 5. You declare it's an int, and then you compile it. And in that compilation step, it makes sure that all of your operations are being done correctly because it has types. So it makes type guarantees. And in fact, since you're working in an IDE with Java from the beginning, most people work in an IDE, interactive development environment, you catch these mistakes before you even compile. So by the time you compile, you know that your code's actually going to work. And in some sense, it's really nice. But then maybe a year or two into programming, you get introduced to a dynamic language like JavaScript or Python, and it's interpreted, and you're like, wow, this is much faster to work with. It's much more fun. It fails sometimes in ways that are not very graceful, but at least it compiled, at least it ran, and at least I got to see it partially fail. So I saw my web page load, and like, oops, that image didn't load, but it was cool to see my web page load. It's fun. And it's part of why people fell in love with JavaScript, I think, is like, it runs. Sometimes it doesn't completely run properly, but it runs. And then, you work in the industry for a little bit, and then you learn some hard lessons about interpreted languages. And you start to realize, that compilation step that I hated about Java, It turns out that's actually kind of useful.
Yeah, I'm with you, right? I feel like Python is the same boat, where many people who enter the development world today start with either JavaScript or Python, just because it is so much more snappy and easy, right? But I think you're perfectly right. You're perfectly right. We really enjoy JavaScript, right? Let's not make a mistake. I think we really enjoy using JavaScript at Slack, mostly because it does allow us to have a very small team, move very fast, move very quickly deploy things, be cross-platform. And let's not forget that JavaScript has gotten like wicked fast over the last 2 years. I met some of the Google V8 folks a few months ago and inquired how the heck they managed to make regex arrays so fast. If you do regex today in Chrome, it's amazingly fast. And they were like, oh, I'm really happy that you noticed. About like half a year ago, we stopped turning it into whatever the intermediary code was, and we're now turning regex directly to assembly, which I find very, very impressive, right? So yeah, we really like JavaScript, but I think you perfectly have a point where at some point you start shipping Slack. In my case, right, I give Slack to my customers, and there's a decent amount of trust going on, right? Like people type in that stuff, they have messages there, they deeply care about what they put in Slack, and it's really on me to make sure that I didn't mess something up. And the more guarantees I can get for very low effort to say, oh, I'm not gonna mess this up, I'm gonna take them all, right? I'm just happy to have them all.
Right. Okay. So we've got a number of reasons that we're touching on here why TypeScript is useful. Why it is useful to have a compile time step and a typed language. So we've got the IDE becoming possible, because the reason you can't have a great IDE for just raw JavaScript, at least that I know of, is because it's untyped. So the IDE can't really give you great guarantees about what's going on because it can't analyze the code super well. It can't do great, I guess, static analysis or code analysis, whatever you want to call it. And then you've also got this issue at Slack where you're handing off variables from one language to another, and you want to enforce certain guarantees about those variables, and it's useful to do that with a typed language. And then you've also, I guess, just got the fact that this is a giant code base and you're sharing it with lots of different developers, so you want a stricter set of rules, a stricter set of variable typing. Are there any more subtle reasons why TypeScript has gotten adopted by Slack?
I would say there are a few that all come down to just I'm delighted as a developer. Let me just rattle them off real quick. The first one is, and I think we underestimate this as developers that have moved away from Java, right, and like look down on those people that can't really do anything without autocomplete. Autocomplete is pretty amazing. It is fantastic. The fact that my editor knows what kind of properties are available on an object and don't really need to like check every single time whether or not something like web preferences, right? Let's say that I have a property called web preferences. Is that camel case? Is it snake case? Does it have an underscore somewhere? I don't care anymore because my editor knows. And I'm probably going to get a bunch of tweets about like, only real developers don't need autocomplete, but it's so convenient. And then there are two other reasons why I really enjoy TypeScript. One is I think we're sort of observing a Betamax versus VHS fight between the various typed systems. And TypeScript seems like the one that has been adopted the most widely, right? With Google adopting it and various other companies. If you heavily rely on node modules, your chances of finding typings for a node module that is not written in JavaScript are extremely high. Not written in TypeScript, right? So let's take something like React, which is famously not written in TypeScript. You can still find types for that, and it's very easy. And that also cascades down to some of the lesser known modules. So it's very easy to integrate TypeScript with a typical NPM world. And then the third reason is that TypeScript by itself is just extremely cross-platform. It doesn't make many assumptions about your device. It runs perfectly fine with all editors. It runs just fine on all operating systems, Linux, Windows, Mac OS. And as a company that is building a cross-platform app and has developers on like all kinds of machines, that was pretty important to us. So in summary, we're pretty big fans of TypeScript. I do feel like there are a few downsides, but in summary, it's pretty amazing. I will heavily recommend it to anyone who's going to listen to me.
Mm-hmm. Yeah, so we've now motivated why TypeScript is useful. And I think we can now get into talking about the process of migrating Slack's code base to TypeScript, because it was not originally in TypeScript.
That is true.
And you were mentioning this earlier, but that basically it's easy to port a JavaScript code base to TypeScript gradually. So let's start to talk about migrating that code base to TypeScript. Give me an overview for how that narrative got started within Slack when people started to say, maybe let's just try to migrate this, and then how that caught on.
I think for us it was maybe we were in a situation that maybe many people find themselves in. We had a bunch of bugs, a lot of features we wanted to build, no time, no people, hiring is impossible, the typical story. But we always had in the back of our minds that we would like more guarantees and assurances about our code, and especially about that layer between JavaScript and the native world. And we were evaluating a few options, But it was very clear to us that a rewrite would not be possible. Like, there's no rewrite going on. We can't just like drop everything for a month and completely rewrite the application. And I think most developers will find themselves in a situation where they can't just like take a break from what they are normally doing to go off and like rewrite the whole application in something else, right? And we keep seeing these jokes on Twitter where people are like, oh, you should just rewrite it in Rust, right? I think most people don't have the luxury of being able to just rewrite things completely. So it was extremely important to us that we could just like start with a little bit, right? So TypeScript makes that very easy because, as I mentioned earlier, you can just activate it and change nothing. I think it's also important to point out that TypeScript, unless you specifically ask it to, doesn't do anything to your code at runtime. So if you have a JavaScript file and you turn that JavaScript file into complete TypeScript, the output is still going to be normal vanilla JavaScript. Like, a person will not be able to tell that you were using TypeScript. And this is important to us because, you know, we are pretty sensitive about our code, and it's important to us that our code looks on the other side roughly like it looked when it came in. And the way we started is we started with just the compiler. We just threw the compiler in our code base, made it one of the build steps. On the first day, we did nothing. And TypeScript immediately found a few subtle bugs, which is fantastic, right? That's exactly the effect you want to do. Like, we gave TypeScript nothing and immediately started paying off. Like, from second zero, I was like, oh, just so you know, like, deep down in this code, every now and then you're like accessing some properties that may or may not be there, just so you know. So that was pretty cool.
So like those small bugs, were they actually problematic, or was it just you were glad to find them because you said, well, you know, let's just iron these out and remove them?
Yeah, no, those were actual bugs. They were just like too esoteric for any human to ever find. They were one of those cases, you know, we use Rxjs and a bunch of other libraries, and then you have promises everywhere, right? And I think especially when you have these like very, very rich libraries that pass your code through like 50 different methods, and if you look at the stack trace, you never really know where things came from. It's pretty easy to lose track of what kind of properties you can expect to be there and what properties you can't expect to be there. And JavaScript is pretty forgiving, right? Every now and then it's fine. A good example is if you have an object where the keys are numbers, right? So you have an object and there's like key 1, key 2, key 3. You're supposed to access those as strings. But if you use a number, it's fine. JavaScript is pretty forgiving, right? It will try to fix your mistakes for you. So those were real bugs, like stuff we actually wanted to fix. So just turning TypeScript on immediately found like 2 or 3 little things. That was fantastic. And from that point on forward, we just did some experiments just to see how it goes. We had like a few new modules we wanted to write. Slack's code base, very much like pretty much any other JavaScript base, is split up into all these individual little node modules that you can use. So we just started with like single files, and it sort of catches on like fire. Because once you have one file that gives you all these nice assurances, touching any other file sort of feels dirty, almost right away.
Interesting. So TypeScript adds this compilation step. So whenever you're going to build a JavaScript file or a TypeScript file into JavaScript, you have the compilation step where the TypeScript is turned into JavaScript. Does that change the build pipeline at Slack at all?
Not for us, but we might be a special case. I think for most people it would. If you're using something like Babel today, it's perfectly easy to just like make it another step in there, right? In our case, we have something called Electron Compile, and we don't have to go too much into it, but it's like this magical thing that Slack released at some point, which allows you to just give Electron a bunch of code in whatever language you prefer, CoffeeScript, TypeScript, Less, Sass, and we'll figure it out. And we'll just compile it for you. So in our case, it was pretty easy because we can give Electron Compile just TypeScript and it will do the right thing.
What kinds of testing do you have around the JavaScript? Like if somebody submits a change to some random node module, where is testing taking place?
Oh boy, we have a few places. I think the most important one at this point at the very beginning, if we talk about TypeScript, is just TSC, which is the TypeScript compiler, and you just run that. And TypeScript will immediately complain if you have stuff being undefined or, you know, your code is structurally not sound, as people like to say. It's structurally not sound. You made mistakes. And then in addition to that, we have something called TSLint, which is made by Palantir. TSLint, in my very personal opinion, it's a very good tool, but ESLint is maybe just amazing at this point. ESLint is you can define anything in ESLint, right? If you work at a company and you care deeply about how JavaScript is written, ESLint is the answer. It's the Swiss Army knife that allows you to do anything. TSLint is not. TSLint is pretty good. It's really just a linter. It's not a magic wand. Whereas ESLint really feels like a magic wand. So we run TSLint, and then we have some testing suites, the same way you would expect them in any JavaScript app. We have Mocha and Jest, and we just run some unit testing. And then at the very end, and at this point, it's like pretty far removed from whatever language we used. At the very end, we have a very extensive manual testing operation because we, as I said, we deeply care about like all kinds of environments, and somebody's taking a slow Windows 7 machine and running Slack there just to make sure that as many customers as possible have a decent experience.
Right. And, this manual testing, there's a certain contingency of people who are opposed to manual testing. I'm of the opinion that, particularly when you're looking at a really complicated app with a lot of usability like Slack, you really have no choice because you can't enumerate all of the possible tests that somebody could do. All you can really do is give it to some users and have them actually test it. Can you talk about your philosophy or Slack's philosophy around manual testing?
Oh, I'm not sure they can. I'm going to speak for the whole company. I'm pretty sure if I try to do that, somebody's going to be like, "Oh, I actually feel that we don't really." I don't think we have like a codified philosophy at this point, but I can talk a little bit about why we do it and how we do it. I worked at Microsoft before, and coming to Slack, having such an extensive manual testing team is pretty blissful. It feels like luxury, right? Because you just gain so much more confidence. You sleep more soundly at night. You know that it worked on all these different devices. We probably don't do as much unit testing in the desktop app only as we should. We have extremely extensive testing on the back end and the front end. It's super extensive, has every possible testing case defined. But for the desktop world, the one that I work in the desktop world, unit testing only gets you so far because once your application reaches a certain maturity stage, you will just run into bugs that you couldn't think of, possibly. My favorite ticket that I ever received was somebody who sent me an email saying that if you rename the Windows folder, apparently Slack doesn't work as he expected it to.
Oh.
And the developer in you wants to think, why in the world would you rename the Windows folder? Like, why would you do that, right? That's a very instinctive reaction, and I'm fairly certain they would have never done a test case for that. But guess what? We now have our manual testers who are extremely empathetic people and have amazing patience. They now have an additional testing step where they try Slack if you rename certain system folders and just make sure that still works.
Wow. Because users will do that sometimes.
Yeah, exactly. Right. And I think it's also with manual testing, it's just easier to test some of the special cases that are really hard to codify. Like what happens if you open up a bazillion other machines? What happens if you slow down the internet? Like what does actually happen? Because in the desktop world, as opposed to the luxury of like, I sometimes look with envy upon our iOS team, right? Their target is pretty slim. They know pretty exactly what the operating system looks like they're building for. In our case, we don't really know. And let's not forget that Slack is also available for Linux, where people can like pretty much do whatever they want. That's why they run Linux. So manual testing, I feel like, is extremely important if you care about those last 5% of quality in your application. But granted, it's also pretty expensive. Right?
Do you think this interferes with the popularized idea of the continuous delivery, continuous deployment? I mean, I remember talking to somebody who was a continuous delivery advocate, and they were saying, oh, if you have a manual testing step, then you can't do continuous delivery. And I was like, well, I've never worked at a place that takes itself seriously that doesn't have significant manual testing.
Yeah, good question. I'm not sure. I think you can do both.
Yeah. Because
I think ideally, what makes continuous delivery with manual testing hard is that you don't know how much stuff you're going to find in manual testing. Right. That's what makes this hard. But I think if you have manual testing not as your primary testing method, but as your method that allows you to make sure that this last polish is there, and ideally manual testing doesn't find stuff, right? Ideally, everything works. Then I think you can absolutely have continuous delivery. But I also got to say that in the past, we in the desktop team only have some decent trouble with continuous delivery just because we do run into bugs all the time that are pretty esoteric that you can't predict. Typical example would be new Windows releases, right? thanks to the insider build now, we can start testing Slack fairly early. But every now and then we run into a bug. There was a focus bug that involved the creators update, where the Windows creators update had some trouble focusing windows. And that was not specific to Slack at all. That was just, the update just had general trouble focusing windows. And we found some workarounds to protect Slack against that to a decent degree. But those are things I personally think you really only find in manual testing. If you just have real users, like real human beings, trying the things that they would try, right? They wake up in the morning and their Windows receives an update. So I think that's pretty important.
I want to talk some about Electron, because Slack is a wide user of Electron, and this is a technology I haven't done a show on. I absolutely need to do a show on it, because this is how a lot of desktop applications are being built today. And I want to understand more about the difference between an Electron app and a browser window, because Electron is this thing that basically lets you build desktop apps out of the same tools that you would use to build a web app. Maybe you could let's start us off by talking about what are the notable differences between an Electron app and a browser window?
Oh yeah, I'm extremely excited about Electron. So and I think this is the difference between a browser and Electron is a very important one to talk about all the time, and I think it's one that the Electron team, or we in the Electron team, need to talk about much more often, because Electron is not the benefit of Electron is really that you can do 90% of your work in JavaScript and combine that with the last 10% that you really want to write natively. You want to do, the native difficult parts in C++. And I think very often Electron gets mistaken for a solution where people just want to take a web application as it runs in the browser and make sure that it gets its own icon in the taskbar and the macOS dock. But that would really not be the right approach. So Electron is, at the very basic, it's a combination of Chromium to take care of a lot of cross-platform work. It uses Node.js, and then it has this thick layer of C++ around it to do typical operating system implementations, accessing the registry, notifications, working with files, those kind of things.
The process of troubleshooting bugs can be tedious and inefficient for developers, especially as they push more and more code to production. The unlucky developer assigned to bug duty may get bombarded with error alerts and spend hours figuring out which errors to address first. They might have to deal with logs to piece together what happened, or even spend time reaching out to other engineers on their team for help. Bugsnag improves the task of troubleshooting errors by making it more enjoyable and less time-consuming. For example, when an error occurs, your team can get notified via Slack, see the diagnostic information on the error, and identify the developer who committed the code. Bugsnag's integration with Jira and other collaboration tools makes it easy to assign and track bugs as they are fixed. We have a special offer for Software Engineering Daily listeners. Try all features free for 60 days at bugsnag.com/sedaily. Development teams can now iterate faster and improve software quality. To get started, go to www.bugsnag.com/sedaily. Get up and running in 3 minutes. Airbnb, Lyft, and Shopify all use Bugsnag to monitor application errors. Try all features free for 60 days at bugsnag.com/sedaily. Thank you, Bugsnag, for being a sponsor of Software Engineering Daily. It's much appreciated. So, do you find it funny that, for example, I use a Mac, and sometimes I look into the what is it called? What's the thing that tells you what's running? The activity monitor.
Yeah, exactly. Yeah.
Activity monitor. So I look at activity monitor, and I'm looking at what's taking up all my CPU cycles and my memory, and it's all browsers and Electron apps. And I'm sometimes wondering, why am I on a Mac again?
It's a good point.
So what's going on there fundamentally? Do you think what are we using a Mac for in that kind of context?
Yeah, the whole CPU and memory thing comes up all the time, and I think it's a very legit concern. And I think Electron is sort of like becoming a victim of its own success, or JavaScript is becoming a victim of its own success, in the sense that the old mantra was always that you write the best JavaScript if you pretend that you're writing C. But as it turns out, most people who write JavaScript today don't know how to write C. Slack included, by the way, right? So Slack, if you look at your activity monitor, memory and CPU is one of our number one concerns. And it's not that we can't do anything about it. In fact, we're working pretty hard on it right now. It's one of our biggest projects this year, because there's a lot you can do. Slack is still a little startup. We're just 3 years old. And if you move quickly and you just build a good web application as quickly as possible, you do leave a lot of things on the side of the road that you can easily pick up. If you start doing things again and start thinking about your architecture and maybe throw some things out and rebuild some things. And a good example would be the virtual DOM, right? Everybody has been talking about the virtual DOM for a while, but many parts of Slack currently don't have that. And the second part would be that if you have a lot of teams, Slack will end up using a decent amount of memory. And that is also something we can work around, right? We can, instead of giving you one connection for each team, we can combine those connections and be a little bit smarter about how we send you notifications and new messages. So there's a lot of leeway there. And I think if you're trying to find an application that does a very good job, I always look up to Visual Studio Code, who's, I think if you just open it up, uses like 30 megs of memory.
Wow.
Extremely impressive. Very optimized application. I think JavaScript, it's sort of like CGI. If it's done badly, you will notice. You know what I mean? How people always complain about CGI, not realizing how much CGI there actually is.
It's a hilarious analogy.
Yeah. And like my favorite examples for where Node.js is running today primarily is Photoshop, which comes with Node.js, right? Most people do not complain about Photoshop being a shitty web app. Or the NVIDIA drivers on Windows, which also ship with Node.js. But those are places where people don't really notice that it's there because it just works, right? And every single time somebody complains about Slack using too much memory or CPU, I just got to say mea culpa. That is not Electron, that's just us. And also we're working on it. You know?
Yeah. Okay. You mentioned some really interesting things there. So the first, I think, did you say that you wanted to do some stuff in C to improve the efficiency of the Slack Electron app specifically?
Oh, no. This is like an old rule that when you write JavaScript as if you were writing C.
Oh,
so you pretend you're writing C, but you're actually doing JavaScript. Without actually knowing what kind of optimizations you will take, your code will end up being a lot faster.
I see. So what kind of memory, or I assume you're talking about like memory, like freeing and allocating memory more in a more Spartan fashion.
Yeah, exactly. So basically, whenever you run JavaScript today, right, V8 or the various other browsers that run your JavaScript, they will all try to optimize the hell out of it as much as they can. And you as a developer, your main objective as a developer who wants to write performant JavaScript is to make that optimization as easy as possible. And there are some basic rules that apply to all compilers, but I guess the two most notable ones are that you declare functions that you reuse every single time. That's a typical mistake people make a lot, right? So let's say you have a for each, or let's just say you have a for loop or a for each loop, right? And inside the for each loop, you declare a function. So what happens inside the compiler, and by the way, V8 has made this a lot better, but I'm taking this as an example for recent years because it's the easiest one. But if you define your function inside that for each loop, the compiler will not be able to define the function once and just reuse it. It will create and optimize a new function every single time it runs through that for each loop. Whereas if you write C, what you would do is you would define the function first, and then you would say for each item in this array, run this function. So the compiler of JavaScript, the JavaScript engine, can go ahead, see this function, turn that into machine code, and the next time you call that function, it will just immediately go to the machine code. It won't have to interpret your JavaScript again. It can just reuse the same thing.
Oh.
That, by the way, I know we're talking about Electron right now, but I think that is also one of the weaknesses of TypeScript, is that we have so many people today coming out of hacker schools who learn JavaScript and Python, and why shouldn't they, right? Those are the two extremely popular languages, and I can fully understand why nobody really wants to sit down and learn C again, or C# or Java. But if you don't have a typed language background, or like a strongly typed language background, TypeScript can be pretty scary.
Really?
Yeah, because You have interfaces in there, you have enums, you have class extension, right? And to you and me, and I assume many people who listen to this podcast, if you're a little bit older, you went to school and you had to learn Java and C#, right?
Yeah.
And you're like, oh, an interface, easy.
Abstract class, who cares?
Yeah, but you can absolutely be a fantastic JavaScript developer who never had to define an interface.
Right.
Or never had to define class inheritance, or never think about public accessors and private getters or something, right? And those are all excellent developers, but if you employ TypeScript in your company and you really want to like juice everything out of it, you should be prepared and willing to sit some of those more junior developers down for half a day and say, hey, maybe take the day off and just learn about interfaces and enums and those type of things.
Well, if you can teach them in a in a day or a week how object-oriented programming works, they're certainly getting a faster education in that than the academic education. I mean, like that. This is interesting because I didn't expect to discuss the trade-offs between a computer science education and a hacker school education, but this is like a prime example and one I have not discussed before. But it's just like the object-oriented stuff that you learn in a computer science education. You really get that stuff drilled into you, and maybe it doesn't happen so much at the hacker school where it's like, look, just get this game working or get this like CMS tool that we're trying to build working, which is fantastic, and that's a philosophy I love. And probably if you do that a little bit, maybe you can start to understand the penalties of moving fast and having an untyped code base, and you may understand more easily after those trials and tribulations, okay, here are some values in interfaces or abstract classes if somebody sits you down and explains them to you. So does it take significant onboarding when you're talking to these newer developers that are coming to Slack and you have to explain, okay, here's what we're doing with TypeScript, and this is an interface, and this is why we're defining it, and this is how it's going to help us?
I think it really depends on how you define significant. I think there's real value in growing those people anyway in that direction, right? Mm-hmm. Because I think it makes them also better JavaScript developers. Forget TypeScript for a moment, but I think it makes people better JavaScript developers. I think if there's like one magic wand that could fix one of the downsides of TypeScript, it would be that. It would be this notion that TypeScript is wonderful to any person who is maybe coming from C# and is saying, oh, wow, if only JavaScript would be as smart as C#, right? And here comes TypeScript and it's exactly that. But the flip side of the coin is, of course, you mentioned abstract classes, right? Like that's an excellent example of something that is not immediately aware to your typical JavaScript developer. It's certainly something that you need to spend some time on. What we do, or the philosophy that I follow, is that you can sort of define, I want to say like multiple levels, right? You can say, okay, maybe this file, we don't use every single feature of TypeScript, right? Mm-hmm. Maybe we'll just be fine with like the basic types. Mm-hmm. But then you can look some of our abstract classes that we have, right? We have like deep class inheritance, and you see like a lot of angle brackets and like T extends K, and where we do dynamic typing, but still statically typed. That's stuff that to most people doesn't even necessarily look like JavaScript anymore. It's going to be turned into JavaScript, but it just really looks like C#. If you squint a little bit, it looks like C#. So I think if you define those realms and you say, okay, maybe if you want to touch this block of code, go and take a quick course on abstract classes, right? I think that's a real downside.
So this suite of Facebook technologies, the React Native, GraphQL, Flow, Relay, this series of technologies has really impacted the JavaScript ecosystem. Which of those technologies is Slack using, and more broadly, what do you think of this suite of Facebook open source technologies?
We love React. I think React is pretty amazing. I think React might also be one of the biggest boons to JavaScript lately, just because it made development so much easier and so much more performant without forcing people to think about how to do performance stuff. Right? You for a second touched upon garbage collection, right? But this whole notion that React is like pretty smart about just throwing stuff away that it knows it's not rendering anymore. Yeah. That by itself is amazing. We pretty much only use React. We don't use anything else.
No GraphQL.
And whenever I talk, at least not the desktop app. Not that I'm aware. Slack, obviously, this day and age, we have almost 1,000 people at this point. Okay. So surely somebody somewhere has played with it. But we in the desktop team for the desktop app, we are really only using React. We played with React Native for a while. We also played with Flow. But yeah, I'm extremely thankful to Facebook for the gigantic amount of community service that they do. Obviously, a lot of the stuff that they release is sort of tailored to what Facebook needs. But as it turns out, what Facebook needs is also what many other people need, including us. So it's quite amazing.
So when I look at Slack, I see some extremely unique application development. It's sort of like, Netflix had its own unique issues, and then they built their own stuff and open sourced it, and it was really useful. And same thing is starting to become true with Facebook. Are you seeing some things in the Slack world where you're like, oh, this looks like a fledgling open source project that a lot of people could take advantage of? Is there anything like that you're starting to see?
I think the biggest one is probably Electron, right?
Yeah.
We are co-maintaining Electron together with GitHub. To be clear, GitHub is leading the project, and the main engineer, CZ Benz, the one who invented Electron, also works for GitHub. But we have engineers that work exclusively on Electron, and we open source pretty much anything that involves Electron. So Electron Compile is a thing. There's a new Node Foundation project that we recently started called the Node.js Installer. So I think there are things that we try to give back. We try to give back pretty extensively, especially in the desktop app, because sharing things on NPM is extremely easy. And if you ever see anything in Slack and you're wondering, I wonder how they did that, chances are extremely high that you can find it in one of our GitHub repos, right? So we talked about the notifications. You can just check out my Electron Windows notifications implementation. If you wonder how we use JavaScript to call eventually Windows C++ code, it's all in my GitHub repo. So yeah, I think we try to give back, probably not with the same success as Facebook, because hey, Facebook seems to be like currently the king on the hill when it comes to open sourcing extremely successful projects, right? We are extremely thankful. If you come from any other development world, let's just say you come from C#, people do not open source stuff. Right? In general, that is not the default, right? Like most people, I think my assumption is that the very best C# code sits somewhere in some bank behind a vault.
That's right.
Has been written internally for fiscal services, and that's it. Whereas in the JavaScript world, right, the people that truly write the best JavaScript, Twitter, Facebook, they all seem to be very active in the community. Google, very heavily open sourcing stuff. The fact that we have Angular and React fighting each other is, to anyone in the JavaScript world, is amazing, right? It's free and fantastic.
Yeah. Okay. Well, so I know we're nearing the end of our time. I just want to ask one more question. We should have touched a little bit more on this earlier, but you mentioned Rxjs, and we've done some shows about Rxjs, and I think this is an important topic that we should do more coverage of. Could you just briefly touch on why Rxjs is useful to Slack?
Oh, yeah, for sure. So the very basic idea being that if you look at the chat system and if you look at an application, you're really dealing with a lot of streams, right? Dealing with a lot of streams that you want to do transformations on. And Rxjs makes it extremely easy for us to be a bit more functional about our code. And being more functional about our code makes it easier for us to reason about it. And that usually the way this can be expressed is that we just have less code, like overall. We just have less code, which is pretty nice. If anyone has ever heard about a thing called the observable, which has been proposed to JavaScript many times, right? Rxjs has many cool things, but the core thing that we really like is really the observable. We also have the big benefit that one of the core maintainers of Rxjs works in the desktop team, so that makes things a lot easier for us. Because let me be honest, for anyone who's out there, the Rxjs learning curve is steep. It is very steep. But once you get behind it, it just allows you to express transformations you would do on events with a lot less code. And typical examples would be something like mouse clicks, right? It just makes it a lot easier to reason about those things in code in a way that seems to make sense. The same way, I think one of the easiest implementations or examples that I've ever seen is if you compare to the array, how the array has all those really convenient methods that you can just call in the array itself, right? Something like for each or map. Imagine you could do a dot map on an event. And if you find that idea attractive, Rxjs might make you very happy.
Yeah. Are you up against time, or can I ask you one more question?
Yeah, sure, go for it.
Okay. Is there anything that excites you particularly about WebAssembly and Wasm.js? So we've done some shows around this topic. This is the basically getting to a place where there's more interoperability between other language, like, you can compile C++ to WebAssembly, or you can basically, you have an assembly language for the web. What appeals to you about that?
I think that's super attractive, right? Because for many of the cases where we currently have to compile C++, maybe we don't have to in the future. So our build currently takes a decent amount of time. Compiling Slack from the bottom up takes almost 30 minutes, just because we have so much C++ that needs to be compiled, and it's like many different projects, and MS Build like spins up every single time.
Wow.
Make and CMake, right? But a colleague of mine, OJ Kwon, ran an extremely interesting experiment. One of the hardest things to do if you're a chat app that wants to be as good as possible is spell checking. Spell checking is one of those things that is extremely difficult because if you sit down with a product person says, well, ideally, the spell checker would just detect the language and everything would just work, right? As it turns out, detecting language is pretty difficult. Even humans have a very hard time distinguishing Canadian English from American English, right? Like, how do you teach a computer to distinguish those things? So JavaScript is pretty much out the door. We do all of that in C++, but we also do have some trouble because the native module is pretty big. And when you run into trouble, as we talked about earlier, if you run into trouble in the native world, you're probably shooting yourself in the foot. Bad things happen. Anyway, my colleague OJ Kwon took CLD, which is a very popular spell checking library and language detection library, and just compiled it down to WASM. And it seems to work just fine. It's just an experiment at this point, but performance is great. The resulting amount of code that we have is a little bit smaller. So I'm super excited about it.
Yeah. Okay, well, Felix, thanks for coming on Software Engineering Daily. It's been really enjoyable talking to you about all aspects of the desktop development at Slack and TypeScript and everything we've talked about.
Yeah, thank you so much. This was really nice.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!